I tried to make this talk short enough, and also I kept in mind that not everybody is familiar with both of these frameworks. Obviously, I mean, you are trying to learn one of them. So I tried to keep it basic enough that everybody hopefully can follow. And yep, I'm going to try to keep it short enough. All right, so this talk is basically a side-by-side comparison between React Native and Flutter, two frameworks, cross-platform frameworks that has been very popular, especially past couple of years. React Native is a little bit older, so it's been used a little bit more and it's more mature. But Flutter is relatively new, but it's going pretty strong so far, and it has a very good community. And the goal is to show some of the similarities and some of the differences between these two, and hopefully encourage developers who don't have any background in any of these to maybe pick one of them or maybe both of them, play around with them, maybe like them, and build cool stuff with them. In this talk, I'm not going to encourage anybody to use one of these exactly or tell you that which one is better, because it's definitely beyond my knowledge, and I think both of them are really great frameworks. And but based on my experience, because I use Flutter more, so I'm a little bit more biased towards Flutter. But again, it's my personal preference. So a little bit about me. I originally started development as an Android developer, and the last Android app that I built was Chewy's Android app. I was working with a team of I think 6 developers, and I got a chance to work a little bit with Kotlin, but it was like 3 years ago, 2.5 years ago, I would say. And after that, I got interested into Flutter and started learning Flutter. I got a new job, and I got a chance to build an app using Flutter. It's an internal app, but it's in production. And to build this app, I make the backend. So I use Kotlin and Cater for the backend. And it was almost a year ago that we released the app. It was successful. I maintained this app, still adding new features to it, but it's been pretty solid. Since it was really good, the company asked me to use my time to build other stuff. So I got introduced to JavaScript, and I built a messenger app for the company using Twilio services. And the backend service, I used Feather.js, and for frontend, I used Nox.js and Vue.js. And I got interested a little bit into React. So I got a chance to work with React. I didn't build anything in production, but it introduced me to React Native world as well. And I looked into React Native and React, and I realized there are a lot of similarities between Flutter, how they built the system, and React Native. So I decided to make this talk. By the way, this page that you see, it's a very simple Flutter page. You can build it in probably like 15 or 20 minutes. And this is my Flutter handle, and sorry, my Twitter handle, and my LinkedIn. All right, so the basic of these two framework. Both of them are open source. One of them is built by Facebook. The other one is built with Google. If you're interested, you can go ahead and take a look at these GitHub repositories, Flutter and React Native. Both of them are probably one of the highest ranked in GitHub. In the definition of React Native, they're saying that React Native is created for and created to build native apps for Android and iOS. And of course, you can, if you want to build apps with for the web, you can always use React. But they define it as learn once, write anywhere, because React and React Native are very similar. There are different components that you're using different components when you're building building an app using React Native, but the main structure and main coding style, even the language, everything is very similar to React. And it is built with JavaScript, and it's great that you can use ES6, and I think you can also use TypeScript if you're interested to have a statically typed language. On the other hand, for Flutter is Google's UI toolkit for building natively compiled applications. You can build applications for mobile, web, and desktop. Mobile is in production. Its release is stable. Everything is great with mobile. Web is still in beta. It is not yet for production, but hopefully soon, I don't know, maybe by the end of this year or maybe next year, it's going to be ready. And desktop apparently is still also in preview, in developer preview. But the idea behind Flutter is not learn once, write anywhere. It's write once, deploy anywhere. So you can actually share code. You can write code for all the platforms, and you can have it in one repository. Of course, there are differences. You cannot like share UI everywhere, but you can build them, and still you can maintain them within one repository. So we can write once and actually deploy it anywhere. And Flutter is built with Dart. So we will talk a little bit about Dart later, comparison of Dart and JavaScript. But before that, I want to talk briefly about the internals of these two systems, these two frameworks. React Native is built using JavaScript. There are other hybrid systems, hybrid frameworks that are using JavaScript as well, but they're usually being loaded or deployed in a web view. So they don't really have access to the native components. On the other hand, React Native is using JavaScript and bridges to use native components that are actually native for both Android and iOS. So when you're using JavaScript, when you're deploying your code in the debug mode, I think it's using V8 JavaScript engine. And when you're building it with, for the production, it's using JavaScript core, which from what I know the last time, I know that iOS, it's being shipped with JavaScript core, but Android, I think it doesn't have it. So React Native is bundling JavaScript core as well into the application. And Flutter is a little bit different. Flutter has an engine. It's a C++ engine, and it has Skia, Dart, and text. Skia is for rendering. It's a rendering engine, and it is actually used for Android as well. And it has a framework on top of this engine. So if you go to GitHub, you can see that there are two different repositories. One of them is for the engine. If you're interested to contribute to that or look into that, you can take a look at that. If you're interested in the Flutter framework itself, you can check the framework. And it is a layered system, layered-based system. So it has a foundation, and it has animation, painting, gestures on top of that. On top of it, it has rendering, and then it has a bank of widgets. And using those widgets, they have built some specific widgets for Android, which is Material, and iOS, which is Cupertino. All right. So let's take a look at some comparison between JavaScript and Dart, because React Native is written in JavaScript and Flutter is written in Dart. So it's good to know what are the differences, what are the similarities. So for JavaScript, you don't need to have a starting point. You can just define a function and call it from whatever you want. That would be your starting point. But for Dart, you have a main method. And if you're an Android developer, you know that you don't have that. And if you miss it, which I did miss having a main method, Dart has it. And you can do some customization that it's a little bit more difficult to achieve when you're using like a native like Android development. If you want to log something to the screen, you can use console log, just like JavaScript, interacting with JavaScript, so you can do the same. And for Dart, it's print. JavaScript is a dynamically typed language. So variables, they don't actually have a type assigned to them. So you can define, say, variable name and assign JavaScript, and then change it and assign a number to it, an integer to it. And JavaScript can handle that gracefully. But Dart is statically typed. It means that if you're saying that variable name, you can say what type you want it to be. And here you're saying it's type string, which is, if you're familiar with one language, you know that the types are usually like very standard. So you don't see that much difference or that much changes in the types. So you define string name and you're giving it the value of Dart, you cannot change it later and say, I want name to be number 5, because it's not the same type. So Dart is a statically typed. You don't have to always say what you want to be the type of the variable that you're using. If you use the keyboard var, you can just initialize it and later initialize it with anything, any value that you want. And Dart compiler is smart enough to tell you to understand that what type of the variable it is. But still, because it's a statically type, once you assign it, you cannot change the type. But Dart also has dynamic typing. So if you actually really need to use dynamic typing, you can use the keyboard Dart. You can use the keyboard dynamic, and you can change the variable value later, like 5 here in no type, and you can change it to, I don't know, Dart. Just like any other programming language, JavaScript has functions, and to define a function in ES5, you can use function keyword and then the name of the function and the body of the function. You don't have to say what you're returning, what is the type of the result that you're returning, because it's dynamic type. And in ES6, they had a new way of defining a function. You can just use the arrow function. It's also called fat arrow. And this is basically treating function as an object, which is actually an object in JavaScript. In Dart, similar, you have the function name. You don't have the function keyword in Dart. And here you can say that what type you're returning, or you can just ignore that. It is, again, the compiler is smart enough to understand what is being returned. Or you can say what type you want to return. For example, here you're returning Boolean. Also, just like ES6, you also have in Dart, you have the object declaration of the functions. You can just say that what is the type of the function as you use the fat arrow. For asynchronous programming, JavaScript has promises and Dart has futures. This is a little bit too advanced if you want to get too much into it, but the idea is that promise or future is something that might not happen now, but it's like a ticket that you're getting, and in future you're gonna get the actual object. So here in get IP address, you're trying to fetch something, and it is returning a promise here. So fetch knows that when it fetches the URL, fetches this URL, is something is going to happen. There's going to be a response, and it can handle that response, but it's going to return as a promise. And whoever is consuming this function is going to handle the promise using then or in failure cases. Same thing with future, it's just the name is different here. There's an alternative if you don't want to use futures or promise. JavaScript and Dart, they both have async and await. And you can define your function async instead of using promise based, you can say await. It means that you're saying that this function is async. It means that it might take a little bit longer than expected. So for example, here fetch function is something that needs to get the data from network. So it's going to wait for it. It's going to wait for it until the result comes back, and then it's going to use the response, and then it's going to parse the response and return the data. Same thing again with Dart. All right, that's the similarities and differences between Dart and JavaScript. There are a lot more if you want to read about it. I have added resources in the end of the slides, and I can share them. To create Flutter app or to create React Native app, you can use command line. Both of them, they have also support for IDEs. You can use VS Code, WebStorm for React Native, or IntelliJ or Android Studio for Flutter. To create an app using React Native, you can either use the Create React Native app. You need to first install it, or you can use Expo. And I think you can also use React Native itself. You need to install it first. And you can create the project. And once you create the project, I'm going to show you again in next slides that how it's going to look like. But you can use Expo start, and Expo is going to run your application. It's actually very cool the way that they are running the app. Expo is basically you can install it on your Android device or iOS device, or you can run it on your emulator. The great thing about it is that you don't have to actually connect your device physically to the computer, which is I think it's super cool, because in any other platform that you're developing that I know of, you have to actually physically connect your device to the computer to be able to deploy it. And again, you have npm. You have full access to npm and yarn. If you have the packages you want to, when you run the project, when you're sharing the project, the first thing that you need to do is you need to install the packages, install your dependencies. So you can use npm install. There are a lot of other command lines. Basically, everything that you have in npm, you have it here or yarn. And for Flutter, when you want to create the application, you can use Flutter create, or you can use, again, GUI to do that. And when you're running it, you can use Flutter run. You can use Flutter build to build for a specific Android or iOS. And you can do a lot of customization, which helps you to implement proper CI/CD using the command line. And when you want to get install the dependencies, you can do Flutter packages get or Flutter pub get. And because Flutter is open source, as I said, so you can download the repository and switch between the releases. They have stable, which is obviously a stable one. They have beta, dev, and master. Master is the most recent, the most updated. But I personally use a stable because I ran into some issues with beta, and I prefer to use stable. And if you want to check the channels, you can use Flutter channel, see that what installation of Flutter, what channel you are in, and you can switch between whatever channel that you want to use. The project structure here for React Native, again, is very similar to to Flutter. You have your Android project, you have your iOS, same here. You have Android and you have iOS. And these are basically like full Android and iOS projects. So you can, in case of Flutter, you can run the iOS app in Xcode and run it from the Xcode itself. And Node modules is basically similar to Flutter plugin dependencies and Flutter plugin. Like everything that you are getting, it's being added as dependencies. All the dependencies are going to be in Node modules. These are some standard git ignore attributes and Babel config for the configuration of the compiler. And what you care about here mostly is package the JSON, which is the definition of your project, that what you need, what is the name of the project, what is the version, dependencies, dev dependencies. If you're familiar with JavaScript, it's again pretty standard. If you're not familiar, if you know Flutter, this is the counterpart of pubspec.yaml. The difference is that here you have JSON, it's beautiful, nice. Here you have YAML, it's all right. It's not so great because sometimes spacing causes some issues. So pubspec.yaml does the same thing. You have your dev dependencies, you have your production dependencies. You can do some customization, like add assets, images to your project. A lot of configurations happening for Flutter in pubspec.yaml. And everything else, all the components that you're building is basically in React Native is going to be in the root. And it depends how you want to organize it. If you want to, for example, use Redux, you can create a directory and call it, I don't know, reducers or actions. Or you can just put them all into one package, call them source. Again, however you want to configure it. But in Flutter, all the Flutter code that you're writing is living in lib folder. And when you're creating a new app, there's a main file here in lib that is a main.dart. And main.dart is equivalent of this app.tsx, which is a TypeScript. And we will look into that later as well. All right, this is a simple Hello World application in React Native and Flutter. You have the in React Native, you have this app function within this is basically the app.txt that I told you here about. It's this one. And what it does here is that it's a function, you're exporting a default function. It's called app. in index.js, you're saying you're wrapping it in the React Native and returning it and calling it. Basically, it's a component and it's a functional component. We will get into that later as well. And these are some imports in JavaScript. When you're importing, you can use destructuring to get exactly what you want instead of getting everything. We don't have that in Flutter in Dart. So here, what's happening here is that you have the app, it returns something, and it's going to be rendered. And what that something is here is basically just some UI stuff that we have. View, inside the view, you're giving it some styles. The styles are defined right down here. And there's a text that says hello world. And for Flutter, you have the main method, as I mentioned earlier. It's, again, it's something that I enjoyed using it because in CI/CD, it helps a lot to customize your build. And you have this function called run app. To this run app, you have to pass a widget. And we will talk about widget a little later. And here we are basically, again, passing this widget that is the center and the text and a hello world and a little bit of a style input. All right. We have components and widgets, components for React Native and widgets for Flutter. These are basically the main building block of your app. In Flutter, everything is a widget. Your app is a widget. Everything that you're running is basically a widget. But in React Native, it's very similar to. The interesting thing here is that if you're using Android, if you're an Android developer, you're using a lot of inheritance. You're always inheriting from activity fragment, and it makes a little bit sometimes difficult to build customized UI. But Flutter and React Native, they both use composition. And the composition pattern means that you can build UIs using smaller chunks of UIs. Like here, you can build more complex widgets using smaller widgets. You can still also extend the current widgets, which is something that you can do it in Flutter and in React Native. You always extend the component, but it is a little bit more challenging to extend the components to particular components in React Native. You don't usually do that, but in Flutter is something that you can customize. Like if you have a button, you can use, for example, you have flat button, you can extend flat button and customize it the way you want. And there is like a full documentation. I added it to the resources for components and for widgets. Both frameworks. They have really good website, really good documentation. Again, I prefer Flutter a little bit more because there's a ton of documentation there. Flutter has done a really good job on creating UIs for material components and for Cupertino for iOS components. You can see the same thing for Android and iOS too. It's not as much as you have with Flutter, but there's some stuff there. And like for example here, if you're using list view, if you want to create a list in React Native, you're using flat list. If you want to have like headers, you can use section list. But in Flutter, you can use custom scroll view, you can use list view, you have grid view. There are a lot of components that you can use. Again, we see a lot of similarities here too. React Native and Flutter, they both have state in mind. They want to make sure that you're properly handling the state of the UI and the state of the app. So they have built two types of widgets. The first type, it will make more sense if we go with the terminology that Flutter has picked, a stateless widget. Stateless widget is the widget that doesn't actually have a state. It will be rendered once, and if you need to build it, you have to destroy it and build it again. The counterpart of it is the functional components in React Native. Functional component, as its name says, is basically a function. And here, for example, we are creating a text button. The text button accepts some inputs here. We call them props in React Native. And it returns what you're trying to render. In this case, touchable opacity is what captures the tap action that is happening on the phone. So if you're pressing touchable opacity can get that event, and you can have a function, and this function is coming as a props, as an input to this function again. And you can run this function when the press is happening. And here we are just running, we have just the text here that says what can be like, it has a children, so you can add more other than just you can add more than just label here. And also in React Native, when you want to style, you're using style sheet, and it's very much like CSS, but it is with the JavaScript syntax. It's like you're building a JSON object, but it's very much like CSS. So if you're familiar with CSS, it's a huge advantage. On the other hand, for Flutter, we have stateless widgets. Everything in Flutter, all the widgets that you're using, is a class. And stateless widgets class extends this class called stateless widget. So this one button that we are creating here, it has this build method. This build method is basically what is rendering your UI. So you can always, when you are building a widget, you always want to implement all the UI stuff here. So what we're doing here is we have a gesture detector. Gesture detector is very similar to touchable opacity. What it does is it definitely gets more than just one on tap, but here we are just using on tap. You can do long press, you can do a lot of other things. You can do slide, and it captures all of them. Here we are trying to get the on tap, and here we have again a child, and the child is the text, which is the label of the button. And in on press, we are doing some action. So in React Native, we said that we have the props. The props is basically the input of the component or widget. And in stateless widget, we have a class. Class has a constructor, just like many other object-oriented programming languages. And you can pass what is called in React Native props. We just call them just inputs of the class, or construct. You can pass it as a constructor fields. And you can pass also functions. Functions are basically objects in Dart. So you can pass on press, and you can define the function, and you can run it here. This on tap is going to be going to run the on press here. So we said that we have a stateless widget. Obviously, we're going to have a stateful widget as well. Stateful widget, it has a state, and when your app is changing the state, you don't want to like rebuild the whole thing. It's just that just a number is changed. For example, if you have a counter, that only the number of the counter is changed. So you don't want to rebuild the whole UI for that. So this is a really good use case for having a state. In Flutter, you have stateful widget. Your class extends the stateful widgets, and it has a method called create state, and you have to create your state. And your state is nothing but a class that is extending state. And you need to make sure that you are giving it the type, the proper type. The type should be the stateful widget. And just like a stateless widget, your state in the stateful widget has a build method that basically renders your UI. So all the UI that you have is going to be implemented here. You have container in the child, you have a flat button, and on press is going to do some actions. All right. In JavaScript, in React Native, similar, you're importing the component from React, and you're extending the component. If you don't define a state, well, it doesn't have a state. But if you define a state here, it's going to be a stateful here as well. And in React, again, you have this render function, and render function basically returns your UI. So here you have your button. Button has a title, and it has a function on press, and again, it does something. So I intentionally kept this part for the last. You see, we have set state in Flutter, and we have set state in React Native. Very similar. A lot of things that we have seen is very similar. Set state basically tells your widget that what is changed. So here we are changing the count, and we need to call set state to tell the widget or to tell the component that we changed the state, now go ahead and go through there and the widget tree or component tree and do the comparison, see what is changed, and re-render only the parts that are changed. Again, very similar. So this is just one thing that you need to keep in mind when you're working with stateful widgets. All right, that was pretty much it. There are a lot of resources for the Flutter, for the JavaScript. If you want to take a look at Dart language, I encourage you to take a look at the language tour. And Effective Dart is pretty good resource to you can learn the best practices. For that, for JavaScript kind of part, you can also take a look at the Effective JS. It's a book. If you want to play around with Dart and Flutter, there's dartpath.dev, and you can always also, if you're in JavaScript background, you're already familiar with the CodePen.io, that you can add HTML, CSS, and JavaScript. And I again encourage you to take a look at the React Native component and Flutter widgets. They have amazing documentation. Another thing that I did not add here is the YouTube channel, the Flutter's YouTube channel. There are plenty of resources there, especially if you want to learn about the widgets. There are short videos, and it's like less than 3 minutes, 4 minutes. You see that one widget, everything every week is discussed, and it's pretty awesome. If you have any question, I'm here.
I feel like one of the challenges with this setup is that everybody's wondering if the other person is going to be the one who opens their mic. So
Yeah.
Thank you very much for that. Is anybody have a question? Last chance before we start transferring over.
It looks like there's a question in the chat.
Oh, all right. Let me see if I can find the chat again. I haven't used Zoom much, so I guess maybe I should stop sharing.
You can keep it on. I figure while answering people's questions, maybe you'll have to, there's a good chance you'll have to go back a few slides.
Yeah, I mean, okay, I already closed it, but if I need to, I'll share it again. So the question is, how well does Flutter adapt to the native look and feel of the platform it's on? That's a really good question. So Flutter is really good with building the feeling of the native app for both Android and iOS. It's, in my experience, is much easier than React Native to do that. In React Native, if you're a CSS god, you can always build beautiful UI no matter what. You can customize it any way that you want. But if you're not super familiar with like CSS with the styling, React Native, Flutter comes out of the box with a lot of widgets that are specific to the platform. If you want to build for iOS, for example, side-by-side comparison of iOS and Android, then you're building an app from scratch, hello world. The navigation for iOS is different from navigation of the Android. The app bar, the look of it is a little bit different. So it's built for the platform. It's definitely Flutter. I think it's better. So next question is, how does React Native handle more advanced state management, just Redux? Flutter has block, Redux, and provider as options. Yes, Flutter has block, Redux, provider, and you can, so I didn't use any of them. I used MVI myself. The fact is that here you have state. You don't really care about the architecture that you're using for your state, for your advanced state management. You can use anything that you want. You have the set state and you have your component. So the rest of it is up to you. If you want to use Redux, I don't know. I haven't used myself any like block for React Native, but there might be a library that does that. If it's not, you can always like write it yourself. Like for MVI, I built it for myself and I didn't share it. I should probably at some point publish that package. Again, this is these two platforms, both of them, they have great capacity and capabilities, and the rest of it, how you want to architecture your app, is completely up to you. And I'm pretty sure that it's flexible, that you can do a lot of stuff with it. It doesn't have the provider, but I'm sure that if you can be, if somebody can build a provider for for Flutter, it's easy to build it for React Native as well. How important or necessary is context, build context in React Native? Well, context in Flutter, build context in Flutter is something that you're always using. I haven't really used context myself. You can always pass props and you can use state management. I don't know. I'm not sure about that. But yes, there might be a context there. But in Flutter, definitely build context is something that you're using it all the time, because there are a lot of things that are global and you want to get that global from the context, from context to basically your global state. Does Flutter have native extension support? Yes, that's also another thing that is, again, very similar to React Native. At the same time, it's different. Flutter has platform channels, whereas React Native has the bridge. And you can build your native part in Swift or Objective-C or Kotlin and Java, and then create a platform channel, pass messages through that platform channel, and consume it in Flutter. Same thing, kind of same thing for React Native. Okay, how does it compare with Bubble.ly? I'm not familiar with Bubble.ly, sorry.
Farzad, just a heads up. If we can maybe give like another 2 minutes to questions. Otherwise, I think it'd be good to maybe figure out. Perfect,
Yep.
thank you.
All right, so we have 2 more questions. I'm going to take a quick look at that. How can you adapt Flutter layouts to different screen sizes, resolution? I've struggled to get text to scale in size and resources. Well, you can use media query for screen sizes in Flutter, and I'm not sure what do you mean, like you struggle with text, because you can always like change your font size if you want to, adjust the size of the font. But if you want, we can continue conversation after this. I'm just getting started with Flutter built-in test and configuration support. How does this compare with native iOS? You mean the unit test? So Flutter also has unit test, and also it has UI test as well. Unfortunately, I didn't get a chance to use it for my own app, but it's definitely, I'm gonna start building an app hopefully soon. And that's also something that I definitely wanna like keep in mind and use it. But I know that in the documentation, they have a good support for UI testing as well as unit testing. All right, thank you very much for your time, everybody. And I'm gonna pass it to Shalom and Zach.
All right, thank you very much, Farzad. Yeah, we got a clap. Brian figured out how to do a clap. Awesome. No idea how that was done. All right, Zach. I guess before I hand it over to Zach, I should give a thank you to Rocket Insights, my employer, because they've been paying for this Zoom account, even though they don't realize that the only reason I ever use it is for this meetup. All right, guys, take it over, Zach.
Zach, you're muted.
All right. Yeah, apparently Zoom hides my regular chat screen when you share your screen, and I can't see anything. So I can't see anyone's chat right now. But if you have any questions during the talk, please feel free to put it in the chat and we can go through after. So thank you everyone for coming out. My name is Zach Russell. I organize GDG Cloud Philly, and I run a software development consultancy here in Philadelphia. So my background is more on the web side. I've worked on projects where I was doing native Android development and some Swift projects, but I don't have a background in traditional native development for iOS or Android. So with my background, I do a lot of web projects and data projects for medium to large size companies as well as enterprises. And I also work on projects for startups where they're looking to prototype MVPs and to get things out quickly. So as far as my experience with Flutter, my first Flutter project was for a healthcare company here in Philadelphia. The state of Pennsylvania released some regulations where basically when employees are signing in and out for their shifts, they need to now have electronic verification, meaning a GPS signal of where they actually are, so they can make sure that when the state is paying money, that they're reducing fraud. And so the challenge that was posted to me was effectively, can we get a demo in 2 weeks? I built a previous iteration of this specific app for them in React Native. And my answer, if I was going to use React Native, can we get an MVP of this in 2 weeks, is probably no. But then about a year and a half ago, I did a study jam for Flutter and really found it easy to work with and very enjoyable. And so I took on the challenge to be able to build this app in a short amount of time. And so by using Flutter and Firebase, we were able to ship a successful product. And that is the knowledge that I'm looking to share here. The second project that I'm working on right now is for a more enterprise level startup where we're actually building a routing app that is the functional equivalent of what an app delivery would be for someone who drives for like Uber Eats. And so we shall start with the talk. All right, so for starters, we're going to cover Firebase. So what is Firebase? Firebase is traditionally considered backend as a service and was founded in 2011 and was later acquired by Google. And so when I say backend as a service, Firebase is more of a suite of products that is geared towards building, maintaining, and growing successful apps, whether it's web, mobile, or even things within games. And is much less of, we're just a database. And so as things move forward, these types of features are going to be more full and useful. So the first product released by Firebase when it was still its own company was called, it was just called Firebase at the time, but it's now referred to as the real-time database. So data in the real-time database is effectively stored as a giant JSON tree. Which then means that if you're wanting to do any sort of queries, a where clause, all this data will need to either be filtered client side or through cloud functions, which means that there's a lot of data that's going to be moving back and forth, which isn't always ideal. The real-time database has super low latency when syncing between clients. I think we're talking about tens of milliseconds in actual latency between the change being made on the database and it being delivered to client. And in my experience, it's not ideal for larger complex data structures because of the limitation of having to nest everything. It can make things a little frustrating to work with for larger projects. The next is Firestore. So Firestore is the successor to the real-time database and applies lessons that Firebase learned from both the real-time database and Datastore. So Datastore is Google's document-based database that is functionally speaking very similar to Firebase. And basically what ended up happening with Firestore is they ended up merging Firestore and Datastore to all be Firestore, and you can run Firestore in Datastore mode if you so desire. It's a document-based structure supporting many fields and formats. So you have the ability, you have the concept. To put it at a high level, when working with Firestore, the way that you work with it is very similar to how you would work with Mongo. So you have the concept of a collection, you then have a document, the document has fields, you can then nest these documents into sub-collections, and they have some nice support for things like timestamps, geopoints, things like that. So the real-time features are slower than the real-time database, but when I say slow, we're talking about hundreds of milliseconds versus tens of milliseconds. So unless you're doing something like a game where you really need the absolute lowest latency, for most things, a couple hundred milliseconds of latency is not going to make or break the experience of the app. So looking at the real-time database versus Firestore, the pricing models are completely different, but they both have pretty generous free tiers. So for the real-time database, we're talking about $1 per gigabyte of data that's getting downloaded, as well as $5 per gigabyte that's stored. This is going to be a lot better where latency is very important for things like multiplayer games or transactional type data. And this has native support for Unity and C++. Firestore does not. So Firestore here is going to be 18 cents per 100,000 writes, 6 cents per 100,000 reads, 2 cents per 100,000 deletes, and 18 cents a gigabyte stored. And it's very optimal for storing larger complex data sets. I would say that my experience working with Firestore, even on some larger projects for, this medical project, we have 500 employees that are logging in multiple times a day. I've yet to experience actually any costs that have been incurred. So unless you're doing an insanely large app where you're getting millions of active users, as far as Firestore goes, it's very hard to actually incur costs. One of my favorite parts of Firebase is authentication. So when building an app, obviously rolling out your own authentication, which is actually something I'm doing on my current project, is a very tedious and complex task to do, and there's a lot of security issues with it. And so what Firebase offers is a drop-in UI that works virtually everywhere. Web, mobile, within Unity, it can work everywhere. So it's highly secure. So the authentication that you're using is actually going through, Google's rigorous authentication methods. One thing that they also have is HIPAA compliance, which is important for obviously medical projects. In order to get the HIPAA compliance, you actually have to use Google's, it's like a step up from Firebase. It's their identity management platform, I think is what it's called. But in order to migrate from Firebase Auth to the Google identity management is literally one click. And you then have HIPAA compliance. The libraries are the same, the implementation is the same, which is really, really nice when you're working on multiple types of projects. You don't have to actually worry about, is this version of auth HIPAA compliant or not? They also support multiple login methods and providers. So built in, they have the username and password auth. They have phone auth, so they'll send you a number, the verification code. They have Google Auth, Facebook Auth, Twitter, GitHub, and new is they now have Apple's login, which coming up very soon is going to be a requirement if you're using something like Google Login. So it's nice that they provided in here. And this also works within Flutter. So the next thing is Firebase Cloud Functions. So this allows you to run a lot of business logic without having to actively manage servers. So Cloud Functions support multiple languages. So they support Node 8 through 10. They support Python, Go, and as of this week, they now support Java. They have very useful Firebase-specific triggers. We're talking about things where you can pull from Firestore or real-time database CRUD operations, so create, read, updates, or deletes. So a good example for a way that I would be using this a lot of times is when we're actually creating a user in Firebase, we want to actually scaffold some sort of data within the database itself. And so you can actually have a trigger for when someone logs in, and we can actually create the user data and any sort of background methods that need to be done without actually doing this on the client side, which can be definitely performance. There can be a performance hit if you're running this locally and then have to actually send the data back up to the database. They also have cloud storage triggers. So you can, when someone takes a profile picture and uploads it, you can resize it or things like that. They have pub sub triggers if you're actually having events that are coming from different channels. And there's a bunch of other triggers that I'm not going to get into here. So the next thing that they have is Firebase push notifications called FCM. This is something that I really enjoy working with because dealing with this through native platforms, through Apple and APNS is a huge pain. So it's 100% free for all platforms. There is absolutely no charges associated with using this. They give you all sorts of advanced targeting where you can actually target people based on device, based on location, and then if you're actually using some of the other Firebase features, you can actually start sending targeted push notifications based on user behavior. You also have the ability to customize notification content per message. And there isn't actually a requirement when you're sending notifications to actually have to code. So the example here is you can actually go through their web UI and compose a message and send it to all clients without needing to code, which can be useful if you have apps where you have non-technical stakeholders that need to send something like a one-time message to users. You don't have to build anything to get that to work. And they also have support for A/B testing and analytics within their platform. The next thing that they have is app distribution, which is a unified way of distributing beta apps for both iOS and Android. It's scriptable and fast, so there's no sort of approvals that you have to go through, and you can deploy it through the CLI, as well as being automated through GitHub Actions. If that is something you're interested in discussing, feel free to ask, as well as through the web UI, where you can upload the APK or the IPA, and it can send it through that. It also integrates closely with their Crashlytics, which is useful to get pre-release insights of crashes. In my experience, sometimes using other crash reporting platforms, it's a little bit harder to actually distinguish things when you're sending things through beta channels. And it's pretty easy for testers. And when I say pretty easy for testers, I mean Apple again. So for Android, it's basically plug and play. You upload the APK, you add users by email, and you send it to them, and everything magically pretty much just works. For iOS, it's a little bit more challenging. So what you actually need to do is get either their IMEI or their Apple ID and actually do a complete separate build of your app that of your testing version of your app that then has that their device information in the app itself, and that's the only way you can distribute it. In my experience, it's way too frustrating to do this with testers, especially at scale. And so what I generally do is just use TestFlight because it's honestly easier. The next thing that they have that's really interesting is predictions and ML kit. So one thing that I've been looking to do a lot more professionally is actually use ML in a lot of workflows. And so I've been using a lot of Google's ML products. And for example, we're using Google's translation services to actually provide translations for Under Armour to be able to translate certain types of text for all countries in the world. And what we've actually found is Google's translation service that is really, really, really cheap. It actually works as good as native speakers. So one thing that we have here are going to be the predictions, which allow you to segment your app's users based on behavior. You then have the ability to personalize the content that's being served within the app itself. You can then customize the marketing campaigns, as well as export this data for BigQuery to do further analysis, any sort of big data that you want to do, as well as utilize some of their ML capabilities as well. You then have the ML kit, which is production ready for a lot of common use cases. So you can do OCR to extract characters from images. You can do facial recognition to detect a face, as well as image labeling. You can run inferences either on device or in the cloud, which is very, very interesting to do, as well as being able to deploy custom TensorFlow light models. So if you have your own custom model that you actually want to serve, for let's say you have an app that recognizes cats, and you have your own trained model that you want to use, you can actually deploy that right within Firebase predictions and not have to worry about managing the infrastructure. And then you also have the ability to train new models using AutoML. A new thing that Firebase has is Firebase extensions. They're reusable apps. And when I say apps, I'm meaning this in the sense that there's no code and it's just a thing that you can install project-wide to handle a lot of common functions that Firebase does not. So this is Firebase basically acknowledging that there's certain limits within their platform, but there are a lot of things that you actually do in a project that is shared between projects, and these are very common ones. One thing is resizing an image when uploaded. Instead of having to create, write, and maintain your own function that does this, you can have this just deployed in one click with your app. Exporting data to BigQuery is something that's really important. So I have clients that are effectively doing, they have all of their app data that is stored, and then they're actually doing exports every day that is then sending all of the activity that's happening with the app, signups, registrations, sales, whatever, into BigQuery, which are then visualizing later down the line through Google Data Studio. Another thing is sending emails. So someone actually signs up for your app and you want to send a welcome message. There's actually no easy way to do this within Firestore or within Firebase. You'll have to actually set up your own mail function, connect to a third-party mail provider, and do all that. And it's kind of tedious. So this is definitely a useful one. The next is syncing users with MailChimp. So you can actually add registered users to some sort of MailChimp campaign, whether you're doing drip messages or just a more ad hoc mailing list. It's also, again, one click to configure, as well as text translation. So the next here is Flutter. So what I'm going to say here is there's definitely some overlap between me and Farzad's talk about some of the underlying internals of Flutter. I'm probably going to skip through them because we don't need to hear it twice. So the first thing to look at with Flutter is that it's based on the Dart language. So Dart is a cross-platform programming language that was developed by Google. It was originally released in 2011 and was planned as somewhat of a replacement or a preprocessor for JavaScript. That never really materialized completely. However, Dart has always been able to compile directly to JavaScript, and this is something that is still used. So Dart itself as a language is object-oriented and C-style syntax, and it has a very extensive package ecosystem at pub.dev. So what is Flutter? I'm going to skip past a lot of things. So Flutter offers full native performance on iOS and Android. One of the goals that they provided within this was basically they're offering 60 frame per second performance at pretty much all times. And in my experience working with Flutter, it is rare that you're going to run into issues unless you're doing complex animation or processing where you're going to get less than 60 frames. They have an extensive standard library that's built out of components, which are widgets. They have really, really nice support for theming with Material UI, as well as Apple's native Cupertino. They use Chrome's Skia rendering engine. And my favorite feature is hot reloading, which React Native also has. One of the most interesting things that's promised with Flutter is being able to run everywhere. And so the first thing that they offer is Flutter for Web. They allow you to extend an existing website as well as build a new one. They have full support to run in progressive web application mode. They also support responsive UIs. The gotcha here is not all extensions work for web. Most of this is logical. If you're doing something that is using a native feature, I don't know, maybe GPS or something like that, though technically computers can use GPS. They may not support it, and this is something that extensions have to explicitly support on a one-by-one basis. All of Firebase's extensions or packages on PubDev do support web. So definitely a plus here. One interesting example of what I'm doing in my current project is, so we're building the driver app. And so that is native. And so we have a lot of stakeholders in the company that we don't necessarily want to have to distribute a version of the app to say, hey, this is what we're building. What do you think about this? And so we've actually been able to build a CI/CD workflow where we're actually building the app to completely to run within web for each pull request. So we can actually have a complete preview, functioning preview of the app directly within pull requests. So what we're doing is so there's functionality as well as a UI aspect that we're pushing separately to allow stakeholders within the company to immediately see the changes. Flutter for desktop also exists. This is in alpha. So currently it fully supports end-to-end building of macOS apps from create Flutter app to actually sending it to the Mac App Store. And Windows and Linux are in technical preview. And so the big thing with Flutter that you're going to see here and contrasting to React Native is that while React Native obviously can run for web, it's you're actually still maintaining separate code bases. And while they maintain the same coding style, being able to actually write once and deploy everywhere, at least in the future, is very valuable. And so the other interesting development with React Native announced last week, I believe, by Microsoft, is that native desktop support for React Native is coming. I don't know what that's going to look like. So I'm going to skip past widgets. So the next thing here is theming within Flutter. So you have the ability to use either Cupertino or Material. So Material supports Google's Material guidelines. They have a lot of robust supports for customizing, which includes completely, defining your own theme, as well as effectively writing a subclass of your theme. So you're importing a default theme and just modifying specific values of it, as well as full support for Google fonts within the app, which is actually really nice. Within Cupertino UI, it implements Apple's iOS design language and supports pretty much all the common widgets that you'd want to use. So one thing to consider here, so the last time I gave this talk was to Philly's Cocoa Heads, which is the Apple development user group there. And one thing that is different here is that while this UI is native feeling, it technically isn't native in the sense that everything is still being rendered through Skia, which means that there are some differences that you're going to see, definitely with things like animations, though things are now getting a lot better within the latest Flutter support for working with animations. In most cases, it's not an issue. Probably my favorite part about developing with Flutter is Android Studio. This is something where I've been historically a Vim user for almost a decade and have effectively fought using IDEs my entire career. And working with Android Studio has actually made me move to using a lot of JetBrains stuff. So it's a free IDE that's based on JetBrains IntelliJ. IntelliJ is also effectively very similar. And they have first-class support for Flutter and Dart from a coding perspective, from running and debugging perspective, as well as a lot of their refactoring options is amazing in my opinion. A lot of this functionality now is also being ported back into VS Code, but in my experience, I've had a lot better of a time developing within Flutter, within Android Studio versus VS Code. So the next thing here is Flutter Inspector, which is a powerful tool that allows you to inspect widget trees. So very similar to the web inspector in any of your web browsers. It works both within a web view or within an editor. So they have the ability to run the Flutter Inspector within your web browser, and you can inspect things through there, as well as doing it through VS Code or Android Studio. They give you a performance overlay as well as profiling. And they also have a nice little feature to switch between iOS and Android gesture behavior, which is good if you're not developing on an Apple computer but want to test what the interface is going to look like, or if you just don't feel like starting up a simulator and actually running the build again, because building things in iOS can be pretty slow. And they also have this really awesome new feature called Flutter Layout Explorer, which was announced earlier this year. It's really hard to explain what it does, but it basically offers a lot of the usefulness that you get within a lot of the web developer tools within Flutter. So I have a screenshot or a GIF that actually shows it a lot better than I can. So what you can see here is you're actually able to modify a lot of the flex values here to fix some of the overflowing issues and out of bounds issues that are occurring. This is something that is extremely useful and makes working with Flutter very pleasant. So next is going to be tips, tricks, challenges, and resources. So within tips and tricks, my recommendation here when working within Flutter and Firebase is to abstract as much logic as possible to either Cloud Functions or Cloud Run. And the biggest benefit here is that there's no need to release a new app version when you just need to change your business logic. So this is in generally best practice in software as a separation of concerns. But within Firebase, it's definitely even more so as a best practice to make things definitely a lot more maintainable, as well as making your app feel snappier because you're not actually doing a lot of this processing client side. So one of the challenges that I've experienced with Flutter is that there isn't necessarily a best practice for global state management. The options here are going to be provider. So when I first gave this talk, provider was not as strongly recommended within the ecosystem. But now, from what I've been seeing, Flutter is definitely moving a lot of their official examples to using these the workflows. But it's still not necessarily the right way to do it, or the way that Flutter recommends. Whereas when you're coming from my experience working with React, or I'm more of a Vue person, there are best practices and ecosystems that are built in, which make things a lot more predictable as well as easier to get support on. So the other examples here are going to be Block and Redux. And so finally, we have a few resources. So the first is going to be Dartpad by Flutter, which Farzad also covered. There's also now CodePen that fully supports the same types of tools. The next is going to be Flutter Gallery, which includes the web port of this. So Flutter Gallery is a native mobile app that will show you a lot of the stuff that you can build within Flutter. Fireship.io is also really useful for Firebase and Flutter tutorials, as well as App Brewery. They now have a free course that is offered on Flutter and is a great intro if you're looking to learn about it. It's over 10 hours, and I highly recommend it. So this is the end of my talk. I want to thank everyone for coming. I'm going to look at any questions that anyone has now. Okay. If anyone still has questions about testing within Flutter, I do have a lot of experience running CI/CD suites within this, as well as running it within the GitHub Actions ecosystem. More than happy to elaborate on that if anyone wants to know more. The Flutter Enterprise Key with App Distro 2. Yes, you can do that, but that again requires a lot more complex setup with servers and downloads, and there's also costs that are incurred with that doesn't necessarily make sense for everyone.
So I guess we'll give everybody a few more, like another maybe minute to write their question. Seems disinterest in being on video and having their voices heard.
Oh. So the question, can you talk about your experience with authentication for a specific set of people, for example, employees, and not allow the whole world? This is a really good question. So this is actually something that I implemented for the medical app that we were releasing for this specific issue. And so there's also an admin portal side of this. And so where basically shifts got scheduled and we were able to run imports and exports. And we effectively didn't want to allow anyone to be able to sign up. And so within the authentication for this, there's a couple ways that you get this working. So the first part is when you're embedding the Google Auth methods, there is an optional parameter that you can set to pre-fill a domain. And so what that will allow it to do is it won't actually force it. But for example, if you have, you set it to google.com, what will happen is when you actually go to click sign up or sign in, and it asks you to log in, it will say, enter email address, and it'll say blank and then @google.com. That can be deleted, but that will actually help at least some users get in. And then the rest of this that goes is, will happen is the after the on-sign up method. So there's a callback for the sign up with username and password or sign up with Google provider. And in the callback for that, you can actually see, you can have it test against to create a field in Firestore. And you can then set security rules to make sure that only someone in an authorized domain can write to a specific collection. And then if that then fails because they can't write to a document in that collection, you can then have a way of handling that. You can feel free to reach out to me and I can show you the specific code examples that I have for this. But it's definitely something that I didn't find that existed when I originally built this, but it wasn't that hard to do.
Would you ever use a Google Cloud function as the point for stopping it?
No. because you need things to be something to handle at client side as well. And so even if someone signs in with a Google account, because the Firebase auth itself is free, there's not really an issue of people like, DDoSing your service to do that. And then the Firebase security rules, basically you're only doing one write to that. So it's effectively, at no cost. So we're talking, 18 cents per 100,000. So I typically handle that just within the app's code when things fail.
Nobody's asking
Any other
questions?
questions?
Oh, looks like we got another one. Oh, wait, no, that wasn't a question. That was a statement. I guess. Oh, there we are.
So what is Flutter's reasoning for having different classes for Cupertino and Material versus importing the appropriate class for each build? So the reason is basically you don't have to use Cupertino on iOS. It's only something that you can use if you want to. So for actually most of the apps that I'm building, or all the apps that I've built, I haven't used Cupertino at all. I'm just using the Material. And so this is only something that you need to use. You can use if you need it, and you don't have to if you don't want to. What's the best way to get Cupertino on iOS and Material on Android? So you basically, the way you would do this is you have the ability to effectively just serve different views to different devices. So you can do a conditional statement to look at what platform you're on and actually load a different viewer screen based on that.
Looks like Jeff's trying to steal your ability to answer questions. All right. I guess it seems like that's the end of the questions. Well, thank you very much, Zach and Farzad. Those are both, I mean, at least to me, very interesting talks. I guess everybody else can speak for themselves.
You're cutting out there.
Superb. I literally just upgraded my internet to solve this issue, and it's made no improvement. Thank you, Xfinity and Comcast.
Good use of money.
Yes, exactly. All right. Well, thank you very much. I guess, do you guys have maybe some point of contact in case anybody wants to shoot you questions that you want to maybe post in the meetup event? That way it's a comment where anybody can get access. Would that appeal to you guys?
Yeah, that's fine by me. You can either reach me on Twitter at Zachary R. Russell, or through my website, zachrussell.net. hello@zachrussell.net is my email.
Same here. You can reach out to me using Twitter. I just posted it at Farzad Barzin. Or you can send out an email to farzad@vexrealty.com.
Thanks
All
very
right.
much, guys.
Awesome. All righty, guys. Well, have a good night, and I guess go enjoy your couches again.
Thanks, everyone.
All right. Bye.
Well,
Thank
bye.
you, everyone. Have a good night.
Thank you.